Hi guys, my name is Ilia and I'd like to talk today with you about unit testing things in Android, and specifically we'll get to test-driven development in Android. So one of the questions I asked all the time I come to a new company for an interview for the last 3 years is, do you have unit tests in your project? What is the test coverage in your project? And it stopped working as soon as we got to actually doing something. Okay, so here comes the question. Who of you guys have unit tests on the project? 4 people? 5? Okay, so that perfectly corresponds with my experience so far on the interviews. So the next question that comes is, how do you know your project actually works? And most of the time it means that you're testing it manually. It's software developers testing it first, then QA developers testing it, then maybe some focus group among managers and this kind of things testing the project, and it goes to prod, and hopefully prod doesn't find some new bugs. But the question is, how can we improve this thing? So unit tests. What is a unit test? It looks as simple as that, and I think even for the people who never ever worked with unit tests before, it's pretty much readable. So what we know from this test, first of all, we get the idea what's the object under the test, some object to test that we have here. Then we get the idea that this object should have a method called sqrt, and we have some expected result from this method, and that's all. So the unit test, in a nutshell, is one simple question you ask to your code and you expect the proper answer. And if the answer is something else, then this test fails, so something is wrong with your code. This way we test small chunks of your projects. In most cases it's either class or the method. And the unit tests are considered the foundation of the testing of the project overall. As you can see, the unit testing here lies as a foundation of this pyramid, and integration testing, UI testing comes on top of that. And manual development even represented not as a level of the pyramid, but as a separate entity here, because manual testing is something we can never avoid. We always should have it. We just want to make the QA guys' life a little bit more boring with less things to find. Problem is, in most cases, what we see instead of a software testing pyramid is the software testing ice cream cone, where we have manual testing that rules everything, and then some plans may be doing automated testing somewhere later. So what comes next? What benefits does unit test grant us? First of all, despite calling it tests, unit tests are first of all a documentation. As you already seen in a very, very simple example that I showed, unit tests give you some information about the thing you're testing right now. It gives you the way how this thing operates. If you come to the project that actually has unit tests and you need to make some changes to the project, or for example you need to use some module from this project in some new place, unit tests are the thing number one that gives you some information on how to use this code. And what is very important, unit tests are never out of date, because if they compile, if they pass, it means they are actual for the code shown. They might not cover some feature, yes, but they will never lie to you. They will just not give you some information. Number 2 is making refactoring really possible. What we mean here, refactoring should always be the change that not changing the behavior, it's just changing how code is organized. But if you make a change to the code that is not covered by unit tests, what's the next thing you will do in this situation? You will test this code manually to make sure that it's still working. But if we talk about some complicated logic and sometimes even time-based logic, it's hard to say is it still stable or not. If this code is covered by unit tests, what you can say for sure is that if all the tests passed before you made some refactoring, then you make changes, run tests again, all the tests pass, you didn't break anything. That's some good news thing to know. Adding new features without risks, same as refactoring. When you add some new feature or maybe change the behavior, you always want to know that you only changed what you expected to change. You only added some particular thing without breaking old things. Again, you have a description of your old behavior, and if it passes, it works. Continuous testing. If you do not have CI in 2019, you most probably need to have it because it's now very easy to set. It makes sense even if you have 2 developers on a project, and it integrates pretty well with unit testing because what you do is setting up CI with setting your CI the way it runs unit tests every time it builds the project. So this way you always know that when your project is built, it's also tested at least to some degree. So you make sure that your project behaves more or less properly. And one benefit, which is getting outdated nowadays, but it's still very useful. If somebody of you still work with Java project, but they really want to move to Kotlin, you can set up Android unit tests the way that tests are written in Kotlin. So you can still have your project written in Java. You're not changing production code. Maybe for some reason you do not want to do it. Maybe you're not sure how it will go. But if you set up unit tests in Kotlin, you can work with Kotlin while having all the project code in Java. If something goes wrong, your prod code is still fine. But at the same time you work with Kotlin, you get some experience with Kotlin. So that's the example of using unit tests. It's main screen from the app we made back in 2017. Some functionality here, like checking the address, building the pass, setting additional options for rides, choosing car class. So it's kind of concurrent to Uber on the European market. All this screen was built without actually running the app, not installing it on the phone. What happened, all the business behavior here was written, tested with unit tests, UI was added to it, and then we had to run it maybe for 3 times just to clean up some UI things, and it was ready. It never created any issues on the prod because we just knew what we wanted to do here, and we did it. As with a normal code, like the project code, unit tests also require some rules. And about those rules, a friend of mine a few years ago told me about the Eurostar talk by James Thomas, which was called "Your testing is a joke." And I really like this line. I like it so much I've stolen it in use here. The talk itself was a little bit different things, but it fits here pretty well because your unit test should be fast, short, and on point. That's the main idea we have with unit tests. And Mr. Martin proposes 5 requirements for unit tests, which are actually pointed to achieve it. So number 1 is fast. Your unit test should run below 50 milliseconds for sure, and 5 to 10 milliseconds is a very good time you need to achieve. Because as soon as you have 1,000 unit tests on your project, even 10 milliseconds per test is a lot of time. Independent. Your unit test should work absolutely the same way, no matter is it run separately as a single test, or it's run with a bunch of other tests, or all the test suite is run. Also, JUnit is running every test as a separate instance of a class. So if you have some dependency on the order tests are called at, you will get yourself into trouble. And no matter what the framework, you really want to have all your tests as separately working entities. It will help you pretty much. repeatable. That's the most important thing about unit testing ever. 10 times out of 10, no matter what's the computer used for testing, no matter your network connection, position on the Earth, time zone, no matter what, tests should either pass or fail. Because if it depends on something that is not the code under test, it means you cannot rely on this test. If it's testing this code in unrepeatable way, so even without changing outside situation, it will pass 9 times and fail the 10th time, you just cannot depend on this test. And if you do not depend on it, you do not run it, and you actually do not have a test anymore, because you cannot believe it. Self-validating. The output of the test should be really, really clear. It either fails or passes. There is no situation like it failed but it returned 9, so that's okay. We know that if it fails but returns 8, that's the problem. But if it's 9, it's okay. No. It should be either pass or fail. It should be really clear, because again, when you start a test set with 500 tests, for example, and you got some failures in it, and trying to figure out what exactly happens here, it might be a problem, especially if you are not the author of those tests. So just make it easier for yourself. Timely. Your tests make sense when they are in place at the required time. In the perfect world and with a perfect test-driven approach, your tests are here just before the code is written. If you add this test after you've created code, well, it helps, okay, but the test wasn't here during the development. And if you add this test after the project is closed, okay, yeah, it's just not giving you anything. To those 5, I'd like to add 3 more. It's not even rules, it's more like guidelines that will make your life way easier. So I'll call them 3 ones. First of all, there is always one logical branch in the unit test. Unit test never makes if statements, unit test never makes when statements, because even if you have something like that in your test, now your test also needs a test for this test. And it's not what you want. One concept to test. Again, your unit test should be as short as possible, because among other things, you need to read through unit tests. So you want them to be simple, easy to understand, and if you need to write a lot of things in your unit test, it means that most probably initialization for your class is problematic, or it has some hidden dependencies or something like that happens, so it's always a bad sign. One way to structure. Same as a code style, if you work as a team, you just want to have some stable structure for your unit tests, so everybody doing it the same way. It just helps, same as code style. With the unit tests, you might have some things that look bad, and they most probably signal that you have some troubles with your tests. Again, if is just bad. So as soon as you have if in the test, it means this test is not reliable. It might behave in a different way depending on something. Assert true thing is more about this specific how JUnit works, because when you do assert true and you try to compare 2 values, say int values, in this case you will either get that it was true or it was false. It's way better to use assert equals x, y, and you will see the output in a more readable way. Evergreen tests, it's you make changes to your code and tests still pass. You make more changes, tests pass, and so on, so on, so on, means test does not test anything. Quite opposite situation, test avalanche, when you change something and now half of your test fails. Okay, you repaired them, or maybe you repaired the code, maybe you just wanted to change something in the code behavior and you actually did it in a proper way, but they failed anyway. And then you change something else, and again, how will tests fail? It means that a lot of your tests depend on the same place in the code. It might mean that it's not that unit test, it might be just coupled with something in your code pretty much. Also, it might mean that your test is very dependable on the exact implementation of the class side. Maybe it should test more about behavior and not how this behavior is implemented. Discussing private matters with your test. When you expose a lot of private things to a test, again, you start testing implementation and not the behavior. Reflection, it's even worse. Testing to string, meaning we test something that is not really useful, and it's a common situation when companies require some test coverage from people who do not want to write unit tests. And they start testing everything. Sometimes they just add implementation, unnecessary implementation overrides for some methods and start testing them. This way they just increase the test coverage until it passes through CI and everybody's happy, but it's not useful. It's hard to name the test. It most probably means that you just do not know what you tested right now. You cannot describe it in one sentence. Most of those problems, from my experience, come from test later development, when you have all the code in place and then you start adding unit tests to this code. So that's it. If your code wasn't designed to be testable, it's most probably not testable, because it's absolutely nature of people to not do the work that is not absolutely required. So if you write a code and you do not plan this code to be testable, you do not plan to add unit tests, you cut some corners, you simplify things. Then when you need to add unit tests, you find that you have some hard couplings between classes you never thought about separating. So yeah, you start with dependencies that are coming from not a Dagger, not a coin, but from good old get instance. And you will not be able to mock this one in unit testing. You will find that your context from Android framework is sometimes somewhere in the presenter or even in, I don't know, Rubelectric retrofit some way. So it might be surprising. And yeah, of course, static methods and variables, they pretty common and they break testability. And the most important thing was unit tests. No matter how many you have, if you do not run it, you don't have any. So you just need to run them every time. You made some changes to the code, just run your unit tests and see how it works. Because if they break, okay, you got a bug, you found the bug before it got to QA and back. You saved some time and money, actually a lot of it. If you try to deploy something to Git, just run tests before that. Maybe you missed something. And of course, as I said, CI should run your unit tests as well. So what's the test-driven development in this case? The common misconception about test-driven development is that it requires you to write all the tests before you make the actual code. It is not. Test-driven development is in fact built on 3 very simple rules. Rule number 1, if there is no test, there is no code. Maybe that's why we have this idea that you need to write tests about everything first. But rule number 2 says that you only write enough tests to fail. So in fact, you will have very, very little of the first test before you start writing code. As number 3 rule, you write your code until the test passes, and then you return to rule number 2, and it goes this way. As an example, here we have our simple test again, but without any checks so far, because some object to test is available. Yeah, we can write a test for it, but it doesn't have any method sqrt. So at this point, we stop writing the test because it's already not compiling. That's okay for us. Test is failing. We need to add some code now to satisfy it. So what we do, we just add a method sqrt and just take the notion that it's returning 0 in this case. It's perfectly fine because in this state the project will build and the test will pass, because test is not checking anything right now. That's okay. We wrote as much of the code as required to pass the test. We do not add here things like mat, sqrt, all that stuff, because it will be code that is not tested yet. And then we go and we add a third check in test SQRT, and now we can add some code to the method, and it will be okay because it's something that will be under test now. Very important thing about unit test in TDD is that it's the first user of your code. So if you see that your unit test is facing some troubles trying to access the object, trying to use API you just developed, it means that those same problems would most probably happen to the code that will actually work with the API you just developed. And it should make you think about what can be changed in this situation. What TDD is not. So first of all, it's not a religion. So all of those are not rules, it's guidelines. It's something that should help you to adjust your approach. Number two, it's not a silver bullet, because yeah, it will not fix everything. First of all, because if you add it to the project that is the already existing project, and this project wasn't designed to have unit tests, first of all, you won't be able to add it to all the classes in your projects instantly. You will have a lot of trouble with including it into existing projects. Martin Fowler wrote a book like this sick about doing it, called it Working Effectively with Legacy Code. So it's a complicated thing to do. But it's still worth it, and if you start a new project, or for example you're making a sub-module of the project, it's a very good thing to have your test from the start. Number three, it's not a universal solution, because obviously it doesn't make sense to add unit tests to the project that you expect to give to the customer and forget about it forever, and it will take you like months to do. Here is a graph to illustrate it. Here says about good design, bad design. We can consider unit tests as a part of good design. It payoffs after some time, after some complexity. If you're working on a very small, very fast project, if it's outsourcing approach, unit tests just do not make sense, because unit tests are a long shot thing. At the same time, if even though your project looks small, but you try to make it a long-lasting effort, you're trying to make it something that will work for a few years, it makes sense to think about testing. Because when you will have to fix something in 1 year, maybe in 2 years, it might be a problem to find what exactly you meant in this particular thing. And we actually got to the end. Okay, thank you guys. I hope it will help you.